Most of what you know about studying and learning in college is probably wrong. And honestly, it's not your fault. Much of the peer-reviewed scientific literature shows that the best ways to learn new information are not actually intuitive. In fact, many of the most popular strategies, like reviewing lectures and highlighting your notes, are not the most effective ways to learn new information. Hi, I'm Rahul. I'm a PhD student now, but back when I was in college, I studied just like everyone else. I spent hours reviewing and rereading my notes. I pulled tons of all-nighters, and I wondered why none of the information actually stuck. It wasn't until I started digging into the peer-reviewed scientific literature that I began to realize that the ways that we've been taught to study and learn don't align with the science. This video is a full guide on how to study and learn effectively, backed by peer-reviewed science. Let's get started. You've probably heard of the idea of learning styles. You have your auditory learners who learn by listening, you have your visual learners who learn by seeing, and you have your kinesthetic learners who learn by doing. And much of the conventional wisdom around learning is around the idea of finding your specific learning style and then studying using that method. However, a review paper published by Harold Pashler in 2009 showed that there's actually very little scientific support for the idea of learning styles. So this idea is mostly a myth. So how does learning actually work? Well, our brains have naturally evolved to forget information rather quickly, unless you actively work against it. This idea is called the forgetting curve, which was discovered by Hermann Ebbinghaus in the 1800s. Basically, most of the information that you encounter on a day-to-day basis fades from our memory pretty quickly, unless you have deliberate review or practice. And this makes sense, because if you did remember every single thing that you encountered every day, your brain would be flooded with useless information. So the real goal of learning is to offset our brain's natural process to forget. So we can think of learning as offsetting forgetting. The biological process of learning is called neuroplasticity, which is our nervous system's ability to change in response to experience. And it happens by three mechanisms. The first one is the strengthening of our synaptic connections. So these are the connections between neurons. The second mechanism is the weakening of synaptic connections. And you can think of this as removing the weak links between neurons. And the third mechanism is neurogenesis, or making new neurons. This is actually a very rare phenomenon. So for the purposes of this video, it's rather trivial. So we can focus on the first two mechanisms, strengthening or weakening existing synaptic connections. The point I want to make here is that when you learn and trigger neuroplasticity, you are actually rewiring the connections in your brain. So how do you trigger neuroplasticity? Well, neuroplasticity requires two things, the first of which is alertness. Your brain is constantly filtering information from the world, and it's only going to rewire itself when it determines that the information is important. So how do you tell your brain that information is important? You do that by actively engaging with the material. When you're alert and attentive, your brain releases a series of chemicals, epinephrine, norepinephrine, acetylcholine. For the purposes of this video, let's just call it adrenaline. And adrenaline is a cue that triggers neuroplasticity. And the good news is, you can voluntarily increase your alertness to increase learning. Just by telling yourself that this information is important when you're exposed to new information is enough to increase your levels of adrenaline and then trigger neuroplasticity. Now, even people with ADHD can focus on something for extremely long periods of time if they believe that the information is either important or interesting. So you don't necessarily need the material to be so interesting that it pulls your attention. You just need to tell yourself that the information is important or that the information is interesting, and you'll learn better for it. The second thing you need for neuroplasticity is focus. Focus is your ability to keep your attention on a singular task. Now, focus isn't some innate talent that you're born with. It's a skill that you can practice and develop. Every time your mind drifts away and you bring your attention back to the task at hand, you are practicing and training the skill of focus. That strain that you feel when you're bringing your attention back to the task at hand triggers the release of adrenaline, which then triggers neuroplasticity. A great way to practice the skill of focus is to practice mindfulness meditation. The idea is to sit still, close your eyes, and just focus on your breath. And every time that your mind wanders, which it inevitably will wander, just bring your attention back to your breath. And a study done by Wendy Suzuki in 2015 showed that just 10 minutes per day of mindfulness meditation showed significant improvements in focus and memory. So just like with muscles at the gym, I like to progressively overload my mindfulness meditation. I used to start with just 1 minute per day, and I've slowly been increasing it, and now I'm at 6 minutes per day. And I plan to keep increasing it too. And already I've started to see significant improvements in my ability to focus for long periods of time. So it's also important to consider when neuroplasticity happens. And you might think that it happens while you learn, but that's actually wrong. Neuroplasticity is actually occurring when you're in sleep or in a sleep-like state. More specifically, it happens during rapid eye movement or REM sleep, which happens towards the latter half of your sleep cycle. So it's critically important to have a good sleep schedule if you want to optimize your learning. There's also this thing called the first night effect, where the first night of sleep that you get after being exposed to new information is absolutely critical for memory consolidation. So the next time you're thinking about pulling an all-nighter, think again, because it might be harming you a lot more than it could help you. Now, if you don't sleep well, there are also non-sleep deep rest protocols out there where you kind of close your eyes for 10 to 20 minutes and get into a sleep-like state. And these protocols have actually been proven to enhance neuroplasticity. And if you want to learn more about it, you can check out Dr. Andrew Huberman's protocols on this. If you just search that up on YouTube, you'll find plenty of resources. Now let's dive into science-based strategies to improve your learning. We'll start with an experiment that was done on grade schoolers. The researchers split students into two groups. Group A read a passage, they studied the passage by reviewing it, and then they took an assessment. And Group B, they read the same passage, and they studied the passage by taking a test, and then they took the same assessment. And which group do you think did better on the assessment? The testing group vastly outperformed the reviewing group. And you might think, oh, this is obvious. And if you're going to take one thing from this video, let it be that testing is the key. Testing is the best way to learn. More specifically, testing is the best way to offset forgetting, which is what learning is really about. So why does testing work better? Well, when you take a test, you're exerting effort, which is the cornerstone of learning. If it feels hard, that means that you are learning. The strain that you are experiencing is what triggers the adrenaline that then causes neuroplasticity. In fact, it's been shown that testing can improve memory recall by up to 50% compared to reviewing the information, which is absolutely insane. I wish I knew that so much earlier. I would have been doing practice tests so much earlier in my life. Another study further explored the effect of testing by splitting the students into three groups. So this time, Group A read a passage and they reviewed it 3 times before taking the assessment. Group B, they read the passage, they reviewed the material twice, then took a practice test, and then took the assessment. And then Group C, they read the passage only once, and then they took 3 practice tests before taking the assessment. So who do you think performed best on the assessment? You might have guessed it, it was Group C, and they outperformed the other 2 groups in the assessment at varying time points, up to a year after the exposure to the material, which I think is pretty crazy. So it was the number of tests that was actually proportional to the performance on the assessment, regardless of how well the students actually performed on those tests. So learning is not about how much exposure you have to the material, it's about how many practice tests that you can do. And it doesn't actually matter if you do bad on a practice test, because it's still better than just rereading or reviewing the information. In fact, it's those moments where you do bad on a practice test that actually trigger the neuroplasticity in your brain. Now, something interesting about this study is that the students from Group A actually reported being the most confident about their ability to do well on the assessment, despite the fact that they actually ended up doing the worst. And the reason for that is because reviewing and rereading the information increases your familiarity with it, which increases your confidence. But familiarity does not equate to mastery, which comes from challenging your brain to be able to retrieve and apply that information. The timing of testing also plays an important role in learning. There was an experiment done, again with 3 groups, where Group A read a passage, had a short delay, took a practice test, had a long delay, and then took an assessment. And there was Group B that read the passage, had a medium delay, took a practice test, another medium delay, took the assessment. And then Group C read the passage, had a long delay, took the practice test, had a short delay, and then took the assessment. Basically, in all 3 of the groups, the time of reading the passage and taking the assessment is the same, but the time at which the practice test was taken to study was varied between the different groups. So Group A took it closer to reading the passage, and Group C took it closer to taking the exam. So who do you think performed better on the assessment? Now, based on what I've been saying, you might have thought Group C, but actually it was Group A that outperformed the other groups. And the idea here is that testing soon after exposure to the material actually improves your retention. Now, this could be because your brain is actually forgetting things the moment after you finish receiving the information. So the sooner that you test, the less information that you're gonna forget by the time you take that exam, and then you can consolidate that information and then apply it in the actual assessment. Now, you could take advantage of this principle by taking a few minutes after listening to a lecture to just think about the material and maybe quiz yourself in your mind. Now, you might struggle with this at first, but that's exactly the point. It's that struggle that then triggers the release of adrenaline that then causes neuroplasticity. So we've talked a lot about testing to improve your learning, and you might be wondering what kinds of tests are best for learning. And it turns out that open-ended, short answer questions with minimal prompts are the best for learning. These are the best because they require you to think and answer questions without any cues, and that promotes active recall and a deeper understanding of the material. Now, multiple choice questions are great, but they primarily encourage familiarity and pattern recognition, which, like I said before, it doesn't equate to mastery of the material. So now you can't control the types of questions that your professors will give you on exams, but you can control the types of questions that you use on your self-tests to practice for these exams. So I encourage you to use open-ended, short answer questions in your practice tests to maximize your learning potential. Now let's get into some tips to optimize your learning. There was a survey done on the study habits of highly effective medical students. And while this was a correlative study, it reveals some consistent study habits that you can easily implement. First one is that these students studied for 3 to 4 hours per day, broken up into multiple sessions a day. They also scheduled their study time and studied for at least 5 days out of the week. Building consistency primes your brain for learning, just like having a consistent sleep schedule primes your brain for sleeping. Also, these students eliminated all distractions. They put their phones away while studying, studied alone, and they told their friends and family not to disturb them while they studied. Also, these students taught their peers. While it may seem counterintuitive to teach your peers, especially in a competitive academic environment, teaching your peers actually deepens your understanding far more than just studying for a longer amount of time would. And finally, these students had long-term motivations. So having your long-term goals and aspirations in mind can increase your motivation to learn. Emotion also plays a role in learning. Now, it's been shown that negative emotions tend to play a larger role than positive emotions. And this is because negative emotions evoke the stress response, which causes the release of adrenaline, which then causes neuroplasticity. Now, you can take advantage of this in 2 ways. First, you could create a sense of importance by linking what you're learning to your greater hopes and dreams. You could also create a sense of urgency by creating an artificial deadline, and you're going to have greater neuroplasticity when you have a deadline coming up. This is actually the same principle by which procrastination works, and that's why you're able to get so much done right before a deadline. Another tip to improve your learning is to take advantage of something called a gap effect. So the way this works is when you're learning new information, just take a pause for 5 to 30 seconds. And what happens during this pause is that your hippocampus starts rapidly repeating that information over and over and over again, and similar to what it does during REM sleep. And what this does is help strengthen those synaptic connections. Another tip to optimize your learning is to interleave unrelated information into your learning. Now, I'm not saying to study 2 different subjects at once, but by relating the information that you're learning to something completely unrelated or something that you already know helps strengthen those synaptic connections as well. You might not believe this one, but cold exposure has also been shown to improve learning. Way back in the medieval times, people actually used to be thrown into cold water after being exposed to new information because the shock of the cold water actually triggers a rush of adrenaline, which boosts your neuroplasticity. And this kind of just goes to show that even hundreds of years ago, people were doing things to improve their learning that the science is now finally catching up to. Now, you can actually implement a more controlled cold exposure by taking a quick cold shower to create a mild spike of adrenaline, just to boost your neuroplasticity by a little bit. The final tip I have for you is to use caffeine. Now, caffeine has been shown to increase your alertness and boost your adrenaline, but you have to use it carefully because if you take caffeine too late in the day, it can interfere with your sleep, which is when neuroplasticity really happens. So if you use caffeine earlier in the day, such that it doesn't interfere with your sleep, it can be a very useful tool to improve your learning. Thank you so much for watching. I really hope this video helps you study and learn more effectively. I've linked all of the studies that I mentioned throughout the video down in the description of this video. If you want to keep learning, click right here, and I'll see you next time.